Hello everyone, welcome to this course. In this video, I'm going to tell you how you can use Google Colab in order to code in Python online. So I'm searching Google Colab keyword in google.com, and the first page comes up is colab.research.google.com. So I click on it. When I click on it, I'm basically, if you're not signed in with your Gmail, you need to sign in with your Gmail, and after that, when you sign in, you see this place. So I'm clicking on new notebook, and when I click on new notebook here, the environment in which I can start coding is shown here. For example, I start with this message saying that welcome to Python programming course with Reza Shahin. So when I run this code, the first time when you run the code, it takes a few seconds, but then it's very fast. So you see, then for the second time, for the third time, it's very fast. It prints out welcome to Python programming course with Reza Shahin. Basically, you can use this open source coding environment for Python using a Google Colab easily to do your codings and do your coding exercises throughout this course. Thank you for watching. Hello everyone, welcome to this course. In this course, we are going to have an introduction to numeric data types in Python. So the first one that we would like to talk about is an integer. So an integer means a whole number with no decimal points. It means, for example, number 1, number 10, number 20. Any numbers with no decimal point, they are integers. Secondly, we would like to talk about float numbers, numbers with decimals, and they can represent fractions. For example, 3.14 or 5.20. These numbers are float numbers. In order to declare numbers and assign them to a variable in Python, we simply write down the name of the variable, an equals sign, and then we are assigning a number to that variable. So for example, here I am initializing a variable called x, and I'm assigning number 10 to this x variable. And here also I am initializing one variable called y, and I'm assigning 3.14 to y. So based on our definition of integers and floats, we understand that x is an integer variable because an integer value is assigned to it, and y is a float variable because a float variable value is assigned to it. By the way, if we want to comment something in Python, we need to have this pound sign before that. For example, when I am writing something after the pound sign, for example, hello from Python, and because we are having a pound sign here before that, it means that it's a comment. So compiler is not going to understand and read these parts. These parts are mainly provided between developers. So if I am developing a code for myself, I can have these comments throughout the code in order for me to have a better understanding of this code. For example, after 2 years, when I come back to my code, I may not remember all the details, but by writing down comments, I can read the comments and it helps me to understand the code better. And also, if I want to, for example, pass this code to another developer, that developer can understand my code better if I'm having some comments in the code. So all these parts that are shown in green are comments, and compiler has nothing to do with them. However, the rest of the code, as you see here, are shown with different colors, and therefore compiler is treating them as something to work with. So here I am initializing one x variable equals to 10 and one y variable equals to 3.14. However, if I would like to see these variables in the output, I can simply print them. So let me comment these parts. So when I type down the print keyword and I type down the X, and when I compile, I see in the output that number 10 is being printed out in the output. So basically, I'm telling the compiler to print the variable X value for me in the output, and it is showing me the variable value. And if I want to print y, I type down the keyword, and within parentheses, I'm typing down the data type, the name of the variable, sorry, and it is going to print that. So when I compile again, I see 10 and 3.14, which are the values for x and y respectively. But when I see this, maybe it would be nice to have some explanation. So now I comment these two lines using a pound sign, and I uncomment this part by printing out by removing the pound sign. And in order for me to have a better understanding of my output, because I may have the print sign for 10 lines, so I would like to have something to be printed out before the variable value, so I can easily recognize which number represents which variable. So I'm adding a comment here. For example, I'm typing down the print keyword, and within parentheses I have two parts and they are separated by a comma. In the first part, in the code, I'm having x equals, and then in the second part, I'm typing down the name of my variable, which is x, and I'm in the second line, I'm having y equals, and separated by a comma from the second part in the parentheses, which is the name of the variable that I would like to print. So when I run this code, you see this time it prints for me x equals and then 10, y equals 3.14. So when I have, for example, 100 lines to be printed, I don't have to remember, okay, 10 was the number of which variable, so I need to go back to in the code and check, etc. Instead of that, I can simply print this text in the terminal, so I understand 10 is the value that represents variable x, and also y equals 3.14. So in this video, we learned about integers and float data types in Python, and we learned how to print them in the output. And also we learned how to comment some parts that compiler has nothing to do with them. For example, now the compiler is not printing this part because there is a pound sign behind that. But if I uncomment this part and I compile, I see 10. Let me go up a bit. Okay, I see 10. Then I see x equals 10, y equals 3.14. So this is being printed, which is this 10 number, because it is printing x, and x is equal to 10. Sorry, I went up too much. And then I'm having this line being printed out, and then this line being printed out. But this line is not being printed out because there is a pound sign there. So if I remove the pound sign and I compile, I see that now I see that 3.14 is now being also printed out in the output. Thank you for watching. In the next videos, we are going to have some coding exercises with respect to initializing and declaring integer variables and float variables. Thank you for watching. Hello everyone, welcome to this lecture. In this lecture, we are going to talk about strings. So a string is a sequence of characters enclosed in quotes. A string can include letters, numbers, symbols, or spaces. So in order to initialize one string, I am giving it a name r equals, and in quotes, I'm having the string that I want. It is, for example, in this case, Reza Shahin. So a variable r is assigned a string, and this string is Reza Shahin. I can have another string, for example, it could be hello world. So this is my second string, and I can also print x for myself. So when I run the code, I see that first I'm printing the string R, which is Reza Shahin, and then I'm printing X variable, which is another string, and it is hello world, and hello world is being printed out here. As you see, also the space between these two words are included. So basically whatever that is included between the quotes is going to be considered in the string. So this is how we declare and we print out one string in Python. Thank you for watching. Hello everyone, welcome to another lecture. In today's video, we're going to learn how to read information from the user through the terminal. So here I'm firstly I'm declaring one variable called integer value. And basically I'm assigning this to my variable. But what is this line? So using the input function, let me have the comment here. Using input function, I'm getting the input from the user. Okay, so using this function, this keyword that is reserved in Python, we can get input from the user. And by default, it is a string. When we get it from the user, by default, we get something as a string. And then I'm having my int parentheses. It is going to convert the string into an integer value. So given this explanation, I'm assigning the integer value that is declared here one input, and in the input and in the first parenthesis, in this part, you see the message saying that enter an integer. And then the user is going to enter a number, and that number is going to be stored firstly as a string because this is a default by Python. And using the int function, I'm going to convert that string into a number. So let me run the code first before giving you another example, so it would be more tangible, I think, for you. So when I run this code, this message is shown in the terminal. Enter an integer. Exactly this message is being shown here. As you see, the program is ongoing because it is waiting for me to enter something, okay? So integer value, and you see this green point here, it says that the program is in this line. So integer value variable is declared here, and the value that is going to be assigned to this variable is the following. We are asking the user to enter an integer that is shown in the terminal, and whatever that I enter here is going to be stored as one string by default. And then using this int function, which I explained here, I'm going to convert that string into an integer. So let me type down. So when I type down 40, it is going to print you entered the integer and then 40. Why? Because I'm having a print function here also, and I'm having this message for the first part separated by a comma from the second part. So in the first part, I'm showing the message you entered the integer, so you entered the integer. And in the second part, I'm having the name of my variable, integer underline or underscore value, which is here. Okay, so using the input, I'm getting some information from the user, and because it is by default a string and I want it to be an integer because I would like to read an integer from the user, I'm converting that string to integer using this int function. Okay, so the second example here is the following. So I'm having another variable called float value, and I'm going to show the message enter a float using the input again function. Okay, and then whatever, as you know, whatever that is entered by the user is by default defined to be a string. It is a rule of Python. Okay, and using the float function, I'm going to convert that string that is stored from the user into a float variable. And that is going to be assigned to this float value variable. Okay. So firstly, I am getting the input from the user. Then, since it is by default stored as a string, I need to convert it to a float because I am looking for a float. If I was looking for an integer, I was going to convert it to an integer. Okay. So, and then the entered value is converted to a float number, and that is going to be assigned to float value variable. Okay, so we are going to get an input from the user, and then I'm going to convert it to a float, and then I'm going to have that float number in the final stage being assigned to my variable, and this variable name is float value. It could be x, it could be y, it could be anything. So let me type down simply x here. Okay, it is x. So x equals this, and then I'm printing out using the print function keyword. I'm printing out you entered the float and a comma and then x. So when I run this code now, it asks me for an integer. I enter 12 and it says you entered the integer 12. Okay, and now it is asking enter a float. I'm saying 3.16, and it is mentioning that you entered the float 3.16. So in this video, we learned that we need to use the input function to get some information from the user, to show the message to the user and store it. And it is by default stored as a string. If we want to have an integer, we need to convert it to an integer. If we want to have a float, we need to convert it to a float because by default it is a string. In order to convert it to an integer, we use the int and parentheses, and within parentheses we put whatever we want, which is the input in this case from the user. And we have the, if we want to convert it to a float, we are going to use this float function parentheses. So for example, I can have int and input. So this is how this is going to work. Int and these parentheses, these two parentheses, and then input with the corresponding parentheses. In the input, I'm going to show, for example, write codes saying that enter an integer for me. Okay. And then the user is going to enter something. It is stored in this part using this input function, and whatever that is stored, because it is in the parentheses of int function, because we're having one int keyword here and one parenthesis in the left and one parenthesis in the right. So whatever that is inside it, it is going to be converted from the string that is by default to an integer. The same rule goes with the float. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we're going to talk about arithmetic operators. So we are going to discuss addition, subtraction, multiplication, and division. In order to do that, we can have the print keyword, and in the parentheses, we can have the numbers, for example, 5 plus 3 or 10 divided by 4. I run the code now. We see the output 5 plus 3, the output is 8. And we are having 10 divided by 4, it is, the output is 2.5. We could also have this message being shown. So the, for example, sum of 5 and 3 is this message being shown out. And we could also have the division of 10 by 4 is, so if I have this message, it's more clear in the output to understand the 8 came from where. Okay, the sum of 5 and 3 is 8. The division of 10 by 4 is 2.5. Okay, and another way to have these is like this. So x equals 10, for example, y equals 4. Let me just choose another number. So y equals 4. Now I could have, for example, z equals x plus y, h equals x minus y, for example. We could have, for example, q equals x multiplied by y, and w equals x divided by y. And then I could print out their values. So let me use this keyword. So I can have this. The first one is z, then h, q, and w. And I could have the message, the sum of x and y. I could have this sorry, I forgot the code. The subtraction of x and y, the multiplication of x and y, and we could have it here, the division of x and y. So let me explain what I did here. So what previously we were printing out the sum directly using the numbers, but I would like to use variables in the print out keyword function. So for example, variable z, print variable z, h, q, or w. To do that, I'm declaring x and y. X equals 10, 20, and y equals 5. I'm having z equals x plus y. So 20 plus 5 is going to be assigned to z. We expect it to be 25. And then I'm having x minus y is assigned to a variable named h. So 20 minus 5, we expect it would be 15, and x multiplied by y, its value is assigned to q, and we expect to see 100 here, and also x divided by 5, the output we expect it to be 4, is assigned to w. And we are going to print the sum of x and y, and we are going to print x, which is this part. Then the subtraction of x and y, which is this part, we're going to print h. We're going to print q to be the multiplication of x and y, and w to be x divided by y. So when I run this code, so let me print out, let me comment this part so we don't see them in the output. So we are having the sum of x and y, 25, which we expected here. The subtraction of x and y, which is 15, 15 is here. The multiplication of x and y is 100. And then the division of x and y, 4. So we see that here we could do some arithmetic operations using variables and direct numbers here. So this is basically how we do mathematical operations in Python. And it's a very good example, I think, for you to start coding as of these videos that we just started, because it would be nice to start coding and get used to the syntaxes and start to see if you're making any mistakes or not. And if you're making any mistakes, check your code with the code that I'm providing for you, and you will understand where the error comes from, and then you can improve from there. So I would suggest you to start coding right away so you get used to all the syntaxes. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we are going to talk about modulus operator. To do that, we are having this sign here. So if we are going to calculate the remainder when one number is divided by another. So modulus operator is going to gives us and finds us the remainder of a division of one variable by another variable. So let me give you an example. For example, here I'm saying that the remainder of 10 divided by 3. And then I'm using this modulus operator here. So when 10 is divided by 3, the remainder is going to be calculated using this operator, and we expect to see the output 1, because if you do the division, you see the remainder will be 1. However, the output of the division of 10 divided by 3 is calculated like this. So we are going to have 10 slash 3. I'm going to repeat. If you're going to calculate the remainder of 10 divided by 3, it is going to be handled by modulus operator. But if you want to know the output of when 10 is divided by 3, you're going to use the slash sign here. Okay, another example is here. So x equals 20, y is 10. I'm having this x modulus y or x modula y. So their result is being assigned to z. Basically, this part of the code is going to do the following. So x is divided by y, and their remainder is going to be calculated using this part of the code, and it is going to be assigned to z. And here we are printing out the remainder of x divided by y is z. So z is going to be printed out here. And we are having the output of division of x by y is going to be assigned to h, and h is going to be printed out here. So when I run the code, we see the remainder of 10 divided by 3 is 1, which is this part. Okay, if you do the calculation, you will see that the remainder is 1. So when 10 is divided by 3, the output is this number, 3 point something, 3.33, for example. And here I'm having two variables, and if x divided by y, their remainder will be 0, because z is shown here. Okay, why? Because they are divisible. So 20 is divisible by 10, so their remainder will be 0. And finally, we are having the output of division of x by y to be assigned to h, and h is printed out here. So the output of 20 divided by 10 is 2. So basically in this video, we learned how to use modulus operator, and we distinguished the difference between modulus operator and division. So modulus operator is going to find us the remainder when one number is divided by another, but division is going to use the slash sign, and it is going to give us the output when one number is divided by another. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to work with floor division. So floor division is going to round down to the nearest whole number. For example, when I have 10 divided by 3, and using the floor division, the output is 3. However, if I have the print 10 divided by 3, we see the output, and it is 3.33, for example. Okay, so to do the division, we are going to use the slash sign, but if we want to have floor division, we are going to have slash slash, so double slashes. Basically, this floor division is going to round down to the nearest whole number, to the nearest integer value. So you see that 10 is divided by 3 is 3.33. So it is 3.33, and it is rounded down to 3 now because we see the output here. Okay, so in order to give you another example, we could have like 11, and we could have, for example, I don't know, for example, 3, and we could have the output x divided by y, and then print the x floor division by y. So if I have this, they're having the same value. I wanted to have another number, but it's okay. So let me have it like 20, like 3. Okay, so x is 23, y is 3. So when I print the x divided by y, we are having the number 7.66. However, when I have the floor division of x by y, I'm having the number 7. Basically, the floor division is shown by slash slash, as you see here, or as you see here, and it is going to round down the output of the division to the nearest integer value. Okay, round down. This is why even 7.66 is rounded down to 7. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to find the remainder of a division. In order to review, when we want to divide 10 by 2, 10 is our numerator and 2 is our denominator. Okay, so we are asking the user to enter a numerator and we are storing it in variable x, for example. Let's say I name it x. And then I am asking the user to enter the denominator, and whatever the user is going to enter is going to store in a variable called y. Okay, so a numerator is asked from the user, which is stored in x. A denominator is asked from the user, and it is stored in y. Then, in order to find the remainder, I need to use the math library and fmod function. So this is my fmod function, and to access that, I need to type down math.fmod. And in parentheses, I need to put two arguments, one before comma and one after comma. So the one that is before comma, I need to put my numerator, and my numerator is stored in variable x as you see it here. So I type down x, and then after comma, I need to type down my denominator, which is stored in variable y. And we can name it whatever we want. We can name it h, we can name it r. It depends on what we want, okay? Then this fmod function from the math library is going to calculate the remainder of the division of my numerator divided by denominator, and we are going to use the print function to print our remainder in the output. So when I run this code, it says enter the numerator here. Okay, so I want to divide 10 by 2, for example. 10 is my numerator and my denominator is 2. It says the remainder of 10 divided by 2 is 0. Yes, okay. So if I type down my numerator to be 11 and my denominator to be 2, now we see the remainder of 11 divided by 2 is 1. So using the fmod function from the math library, we can easily find the remainder of a division. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that calculates the total number of pages required to print a given number of lines, where each page can hold a fixed number of lines. Here, we are using the math library. We are asking the user enter the total number of lines to print. It is assigned to lines variable. Then we ask the enter the number of lines per page, and it is going to be assigned to lines per page variable. Then we are going to divide line by lines per page. Okay, and then it is going to be assigned in pages variable, but we want to round it up. In order to round it up, I use the actually math library, and I also use or call the ceil function from the math library, and in parentheses I type down lines and then lines per page. For example, if I have, for example, uh, 200 lines, and in each page there are 19 lines. So I would like to know how many pages do I need. So 200 is divided by 19. The result, if you do it yourself, will be approximately 10.52. But because we are using the ceil function, the output will be 11. So it is rounding it up. So let me run the code. It says enter the total number of lines to print. So the total number of lines, it's 200, for example. Then enter the number of lines per page. I would say it's 19, for example. It says you will need 11 pages to print 200 lines. But you see that 200 is divided by 19 in this formula here. 200 is divided by 19. But because we are using the ceil function, the output, which is 10.52, is rounded up to 11, and we see that in the output, number 11 is shown. So this is how we can use ceil function from the math library to round up the output for us. Thank you for watching. Hello everyone, welcome to this section. In this section, we're going to talk about if statements in Python. So let me illustrate it with an example. We would like to write a program that checks if a number is positive and prints positive number if it is correct. It is positive, okay? So there are certain situations that we would like to check certain condition in Python. To do that, we need to use if conditions. For example, we would like to say if this happened, do this. If something else happened, do something else. Okay, so this is a logical conditional statement in Python. For example, here we would like to write a program that checks if a number is positive or not and prints positive number if the number is positive. To do that, I'm initializing a variable called number, and I assign number 10 using the if keyword followed by the condition itself, followed by a colon. We are having the if statement in Python. For example, here I'm saying that if that number that we declare to be 10 is larger than 5, then print out the number is greater than 5. Okay, please note that we are having a bit of a space here that is following this if condition. So you start the if condition here, and when you're talking about the statement, the block of code that you want to execute, if this condition is correct, you need to leave some space, and it is automatic. So when you type down an if condition and you enter, usually compilers leave you some spaces automatically. Okay, so when I entered, you see things are going to be started from this part, okay, itself. So it is automatic. So let me run the code. So now the compiler is providing the output for this statement in Python. So you see that in the output, the number is greater than 5. You see that? But if I put here a 15, so I say I am initializing a variable called number that is assigned to 10, and I'm checking to see if this number is larger than 15, do this for me, okay? So when I run, I see nothing in the output as you see it here, okay? So when you see nothing in the output, it means that this part is not passed. This condition is not passed. Why? Because 10 is not larger than 15. So in order to have one if statement in Python, we are having the if keyword followed by the condition. So in this case, we are saying number is larger than 15. Then don't forget to put this colon here as well. Then when you enter, you go for the printing or the rest of the execution of code that you would like to write down there. So for example, I could say if number is lower than 0, for example, print the number is negative. Okay, so this is another if condition that I'm typing down here. Please note that there is a little bit of a space. When I enter, it automatically leaves a little bit of space, so it increased the readability of your code as well, because now you understand that this part of the code execution depends on this if condition. So if we enter this condition, then this execution will be done. So when I run, you see that in the output we see nothing. Why? Because this is 10. 10 is not larger than 15, therefore this if condition is not executed, because this part is not passed, and by passed I mean this part is not true, it's not correct. And also because 10 is not lower than 0, therefore this part is not also executed. So what if I put -10, for example, here, and I run the code? So you see that first it checks this if, and it says -10 is larger than 15. No, then this is not being printed out in the output. But it is checking to see -10 is lower than 0. Yes, so it is going to enter this part and execute this part, and it is saying that the number is negative. So this is how basically we can use if statements in Python. In the following videos, we are going to do some practical coding exercises to understand different situations in which we can use if statements. Thank you for watching. Hello everyone, welcome to another coding exercise. In this video, we are going to talk about if and else statements. In the previous video, we learned already about if statements, but now we are going to include else as well. So we would like to write a program to check if a person is older than 18 or not. Here I'm initializing a variable called age. I'm assigning number 18 to it. I'm having the if keyword here, and I'm checking to see age larger than or equal to 18. So if age is larger than or equal to 18, then colon, so then print out this part for me. So let me first comment this part of the code. So we work with the first part first. So it says that you are eligible to vote. So basically I'm assigning a variable. I'm having again, there are 3 steps. We use the if keyword, we put the condition, and then the colon. Okay, so we are saying that if age is larger than or equal to 18, then if this is true, print out you're eligible to vote. So if I put 10 here, it prints nothing. You see, it prints nothing because 10 is not larger than 18. In this case, we can have else conditions. For example, we want to check, because in the output I see nothing. I get somehow, okay, did I do everything correctly, because I'm not seeing any message in the output. But in order to make sure that you did everything correctly, it's nice to have sometimes an else condition. So if the condition is true, do this. Otherwise, using else keyword, otherwise do this. Okay, so I'm saying that age equals 10. First, I'm checking 10 is larger or equal than 18. No. Otherwise, because it does not pass this condition, print you're not eligible to vote. So when I run, you see that you are not eligible to vote. So it's not going to execute both of the conditions. It is going to either be in the first one or in the second one. Okay, so let me illustrate with another example. So the person age is 22. So this is a program to check if someone can vote or not. Okay, so when I run, it says 22 is larger than 18, so you are eligible to vote. Okay, but if I put, for example, instead of 22, 12, it says you're not eligible to vote in the output. Why? Because 12 is not larger than 18. So this if and else condition is somehow, if the condition is true, do this. Otherwise, say that, for example, you're not eligible. So anything that is not larger than or equal to 18 is going to be included in this else part. Okay, you understand? So this is how an if-else statement would work in Python. We check one condition. If this condition is true, do this. Any other things, otherwise, anything other than the condition that I'm putting there, just include it in the else part. Then you say that, okay, in the else part, it means that you're not eligible. It doesn't matter if the person is 12 years old, 2 years old, 5 years old, or 17 years old. If it's not included in the larger than or equal to 18, it is considered to be else. Okay, thank you for watching. Hello everyone, welcome back. In this video, we are going to talk about if, elif, else statement in Python. So we would like to write a program that assess the mark of a student and grade it based on different conditions. For example, it is going to grade A to the student if the mark is larger than 19, larger than or equal to 19. It is going to issue grade B if it is larger than or equal to 75. It is going to grade C if it's larger than or equal to 15. And any other number, else part, any other number that is not included in neither of these conditions is going to issue the grade F. So it means that if the mark is lower than 49, okay, or lower than equal to 49, it is going to enter this part, because any other number is going to be included in this part, and the only numbers that can be included in this part it means that it is lower than or equal to 49. So let me run the code first. It says grade B. Why? So I'm having the 85 assigned to marks. In the first part, I'm checking if marks 85 is larger than 90. No, so it is not going to print grade A. Then it comes here. When I'm having several conditions to check, as of the second one, I need to type down elif instead of if. Okay, this is something to note. I'm checking elif mark is larger than or equal to 75. So my number was 85, and it is larger than or equal to 75. Okay, it is true. So this condition is passed. Then it is going to print out grade B for us in the output. So if I type down 92, for example, now we see grade A in the output. So now it is 92. 92 is larger than 90. Yes, so it is going to enter this part of the code and execute grade A. So what if it is 55 and I run, it says grade C. So it is 55. 55 is larger than 90. No, it is not going to print this part, therefore. It jumps to the next if condition. Elif, as of the second condition checking, we are going to type down elif. Be careful about it. So elif 55 is larger than 75. No, so it is not going to execute this part. So it is going to jump to next elif. It says 55 is larger than 50. Yes. So it is going to enter this part and execute grade C. Okay. So what if I have number 40? So here, before running the code, I'm going to discuss the detail. 40 is larger than 90? No. Then it jumps here. 40 is larger than 75? No. Then it jumps here. 40 is larger than 50? No. So because 40 is not going to enter any of them, we are having the else part. So if I don't have the else part, nothing is going to be printed out in the output, because 40 is not in any of the ranges above. Okay. But for clarity, I'm putting the else. So whatever that is not included in neither of the ranges, it is going to be included in the else part. So it says grade F. So when I run, we see grade F in the output. So this is how we can have the checking of the first condition, it is F. As of the second condition, when we want to check, we type down elif, and if we are going to check 100, for example, statements, we type down elif. And for the last one, when we want to say, okay, if neither of the above ranges and if conditions is not passed for certain value, we're going to enter the else part. So you see, if I comment this part, we see nothing in the output because 40 is not in any of the ranges that we are investigating using if and elif conditions. Okay, so it is not larger than 19, not larger than 75, not larger than 50. But for the clarity, it's nice to have something in the output so you know when you have, for example, 2000 lines of code, it's nice to know what is happening in each part of your code. So I'm having this else part, and also for validation, when you're having something in the output for validation, it's very good. So here I'm having the grade F being printed in the output because 40 is not included in neither of the ranges. Thank you for watching. Hello everyone, welcome to this section. In today's video, we are going to talk about for loops. So a for loop is used to iterate over a sequence or a range of numbers. So the for loop iterates through each element in a sequence, performing an action for each element. The range function in Python is often used to loop over a sequence of numbers. Later on in higher level classes and courses in Python, when we are going to learn about list, tuple, dictionary, and set, then we can also integrate for loops with them as well. So a for loop can iterate over a list, a tuple, a dictionary, or a set. But this is something that we're going to discuss in higher level courses. For now, we're going to learn how to use the range function in Python to iterate over a range of numbers. Let me illustrate it with an example. So now we would like to write a program that prints numbers from 1 to 5 using a for loop. This is the statement of our program. So in order to use the for loop, we have the keyword reserved in Python for. Then we are having the I. It could be anything that we want. We choose our iteration variable to be I. And then we are going to use the in keyword reserved for this. Range is the function of the Python that we are going to use, and the range is divided by a comma. So there are two ranges in parentheses that we are going to have when using the range function, the starting point and the ending point. So let me run this code. When we run this code, this I is going to iterate over this range for us. One thing to mention is that the starting point in Python for range function is inclusive, but the ending point is exclusive. It means that it is going to iterate over for all I in the range between 1 to 6, but it is going to iterate over 1, 2, 3, 4, and 5, and not 6, because the end is exclusive. So it is the start point that is inclusive, okay? And then we are going to print I. So in the output, we are having number 1 to 5 being printed out. But how does it work? So let me put some comment here. So for the first time, we say that we are using this range function. And when we are having the range function, we need to choose the start point and the end point, okay? Start point, end point. And when we are going to have the range function, for example, here we would like to go over numbers from 1 to 5. So the starting point is 1, and it is going to include 1 because it's a rule in Python. So the starting point is inclusive. So it is going to start from 1 and it is going to iterate until it's 5. But because if I write down 5 here, because the end point is exclusive, it is going to iterate over 1, 2, 3, and 4, and not 5, because the end point is exclusive. Okay, so I'm going to put 6 here, therefore it is going to go until 5. So this is how the range function works. And if I want to explain further, we see that for the first time I get the value 1. Okay, when I equals 1, it is basically having this print function being implemented because we are having print, and in the parentheses we are having I, and I equals 1, so we are going to print 1 in the output, and we see it here. Okay, and then it goes up back again, and I now equals 2. I now equals 2, and it is going to print 2 for us, and we are having it here, and it goes up again. I is incrementing, and we are having the I equals 3, print 3, I equals 4, print 4, and finally I equals 5, print 5. So this is basically what happens in each iteration in this for loop, that we are having this output here. So in this lesson, we learned how to write a for loop. We are having a for keyword and one variable to be defined here, then using the in keyword and providing the range, a starting point and an ending point. Starting point is inclusive and the ending point is exclusive. So if I type down until 6, it is not going to go for the 6th one, it is going to go until 5, okay, until the end of 5, including 5. And for this loop, I am printing I. So I, when it starts, because it starts from 1, I equals 1, it is printing 1. Then I is 2, I is 3, printing 3, I is 4, printing 4, I is 5, printing 5, and that's it. It is finished. The for loop is finished, and these are the output of our program. And one thing to mention here is that this is the range function that we are using to iterate over a range of numbers, and it has two parts in the parentheses, starting point and ending point. They are separated by a comma. In the next videos, we are going to discuss further practical coding exercises, so you would get used to the syntax of loops, of different types of loops, including for loops. Thank you for watching. Hello everyone, welcome back. In this video, we're going to talk about while loops in Python. So a while loop repeats as long as a specific condition is true. So the while loop requires a condition to be true, and if the condition becomes false, the loop stops. So we need to be careful to avoid infinite loops by ensuring the condition eventually becomes false, okay? For example, here we're going to print numbers from 1 to 5 using a while loop. Exactly the same exercise as the previous video, but here instead of for loops, we are going to use while loop. So I'm initializing I variable to be 1 before starting the loop, and then I'm having the while keyword, and then the condition here and colon here. Okay, so 3 parts: the keyword while, the condition here, and the colon. Okay, so I'm going to write down while I is lower than or equal to 5, do these things for me. Okay, while I is lower than and equals to 5, print I, and then increase the value of I by 1. Okay, this sign, let me plus equal, it means that when I'm typing down I plus equal 1, it means I'm typing down I equals I plus 1. So they are basically the same in Python. So I equals I plus 1 is exactly, it is going to do the exact thing as I plus equal 1. Okay, but because it is more concise and more and shorter, we're going to use this way of writing it. But whenever you see this, it means this. Okay, you can type it down somewhere in comments for yourself for a while to get used to it. So let me illustrate it with an example. Initially I equals 1, and when we are going to enter this condition, it checks to see 1 is lower than 5. Yes, it's true. So print I. So it is going to print 1 for us. And then in the next line, we are having I equals I plus 1. It means that I equals 1 plus 1. Therefore, I equals 2. Okay? So this line is exactly like this line. And basically, it means that I equals 1 plus 1. Why? We already have 1 here. So this one is that one. And we also have this I here. And I initially equals to 1. So when it equals to 1, we are typing down here. So now I equals to 2. Okay? So we incremented the value of I by 1 value. So now I equals 2 at the end of this loop, and it is going to check the condition again. 2 is lower than 5, yes. So it is going to print 2. Then it is typing down I plus 1. Okay, so it means that I equals 2 plus 1, therefore I equals 3. But why 2 plus 1? Because we are having this formula, I equals I plus 1. So I equals 2 plus 1. This plus 1 is exactly the same thing here, but we are having 2 because we entered this loop initially using I equals 2, because this is why we were printing 2. So 2 plus 1, now I equals 3. I equals 3, we are going up here again and we are checking the condition. 3 is lower than 5. Yes, it is lower than 5. So print 3 for me. Print 3, sorry. And then I equals 3 plus 1. I equals 4. Okay. And here 4 is lower than 5. Yes. So print 4. I equals 4 plus 1. I equals 5. 5 is lower than or equal to 5. Yes. So print 5. And then I equals 5 plus 1. I equals 6. So I equals 6 now. 6 is lower than or equal to 5? No, it's not. Therefore, it is not passing this condition, and thus it is not going to enter this loop anymore. So this is not an infinite loop, because we mentioned here we need to ensure that the condition eventually becomes false here, and now it becomes false because I equals 6 and 6 is not lower than 5. Therefore, the condition becomes false, and now when I run this program, you see here I'm printing 1 to 5 here. So let me explain it one more time. If we want to have the while loop, we need to initialize the variable a priori to the while loop. So I'm initializing this I here, then I'm having the keyword while, then the condition and one colon, sorry. And as long as I is lower than or equal to 5, I'm going to print the value of I and increase the value of I by 1 unit. And when I'm having I plus equal 1, it means that I plus equal 1, it is exactly equal to this equation. I equals I plus 1. But because it is shorter, we are going to use this one. But we could use this one as well. Okay? So when I equals 1, I print 1 and I increase the value of I by 1 value. So 1 plus 1, it's 2. 2 is lower than 5, yes. So print 2, and 2 plus 1 is 3. So 3 is lower than 5, yes. Print 3 for me, and 3 plus 1 equals 4. So 4 is lower than 5, print 4. 4 plus 1 is 5. 5 is lower than or equal to 5, yes. Print 5. Increase the value of I by 1 value. So 5 plus 1 is 6. And 6 is lower than or equal to 5? No. So it's not going to enter this while anymore. But what happens if I comment this line? So if I comment this line, it is going to have I equals 1. It is going to say 1 is lower than 5. Yes, print 1. And go up again because we commented this line. Okay. I still, it is 1. Okay, 1 is lower than 5, yes, print 1. Again, it goes up back again. 1 is lower than 5, yes. So we are not changing the value of I, so it becomes an infinite loop. So when I run this code, you see it is simply printing 1 again and again. So it is not going to finish because it's an infinite loop. So I need to stop it. Okay, so I need to interrupt it. You see how many 1 it has been printing? Let me go up again. It's not going to finish. So when I go up, oh la la. Okay, so we need to make sure that it is not an infinite loop and it is going to end at some point. This is the important part when we are having the while loop. Thank you for your watching. Hello everyone, welcome back. In this video, we are going to talk about break statement. So a break statement is used to exit a loop, even if the loop's condition is still true. It is useful when we want to stop the loop based on certain conditions. So let me illustrate it with an example. We would like to stop the loop when the number equals 5, okay? So we are going to have a for loop. It is going to iterate over I in the range 1 to 10, and we are having the colon here, and we are having one if statement. So if I equals 5, break. If I equals 5, break. Otherwise, print I. Okay, so when I run this code, it is printing 1, 2, 3, and 4. So let me illustrate what's happening here. So I equals 1 in the first time, and it checks to see 1 equals 5. No. So when I say no, it is not going to break because it's not going to enter this part of the if condition. So this is the if condition. This is the statement that is going to be executed if this condition is true. So in the first run, I equals 1. 1 equals to 5? No. Therefore, it is not going to do anything here, and it is going to jump here and print 1 in the output for us. Okay, so print 1. Then I'm having I equal 2. It checks to see 2 equals 5. No, so print 2. I 3, print 3 because 3 is not equal to 5. And I equals 4, print 4. However, when I equals 5, it checks here. 5 equals 5. Yes? Yeah, that is true. So when 5 equals 5, it is going to execute this part of the code. So it is going to break. When it breaks, it means that it exits this for loop. Okay, so it is going to exit this part and it is going to come here where we have nothing more to execute. So this is why when I equals 5, it is not printing anything for us because this print comes after the break. But if this print comes before the break, it is going to also print the 5 for us. But it is now, let me put it here. So when I put the print here and I run the code, you see that 5 is also printed because when I equals 5, it is going to first print 5 and then checks to see if 5 equals to 5, and then it is going to break. Okay, so it's important for you to know where to put the break and how the output of the program could be different based on where you're putting the break. So when I have the break before the print, when I equals 5, it is not going to print 5. But when the print is before the if condition, it is first going to print 5, then break the loop. So it is not going to go for the I equals 6, 7, 8, and 9 because this loop was supposed to go from 1 to 9. I'm saying 1 to 9 because the endpoint is exclusive, so 10 is not going to be considered. It is going to go from 1 to 9. So it is when we are having I equal 5, it is breaking, so it is exiting the loop. Therefore, I equals to 6, 7, 8, and 9 are not executed here. Okay? So this is how we can use the break statement. When certain conditions are met, we can have the break and exit the loops. Thank you for watching. Hello everyone, welcome back. In this video, we are going to talk about continue statement. So the continue statement is used to skip the current iteration and move to the next one. It allows the loop to continue running but skips executing the rest of the code for the current iteration. Let me illustrate it with an example. So we would like to write a program that skip even numbers. Okay? For that, we are looping over all values for variable I in the range between 1 and 6, and if this I variable is divided by 2 and the remainder of this division equals 0, we're going to continue. Otherwise, if this condition is not passed, we're going to print I. So let me type down this I equals 1, I equals 2, I equals 3, I equals 4, and I equals 5. Okay, so these are the values that I is going to iterate over. So for the first time, when I equals 1, it basically mentions, sorry, let me put this. Okay, 1, if 1 is divided by 2, the remainder would be equal to 0. It is checking this condition. Is it true? No, because it's not true, it is going to print 1 for us. So in the output, we will have the print 1. Okay. Then it moves to the next number. So I is incremented by one value. So we are having, if 2 divided by 2, the remainder of this division equals 0. Yes. So when it is yes, it is going to continue. So this condition is passed. Therefore, it is going to skip this iteration. So it is not going to print anything for us in the output. So it is going to skip. It is going to continue. Nothing happens. Skip this iteration. Okay. Then it is going to increment the value of I one more time. So I equals 3 now. So 3, if it is divided by 2, the remainder of this division, is it equal to 0? No. So it's not equal to 0. Therefore, it is going to print 3 in the output. Then I equals 4. 4, if it is divided by 2, the remainder would be 0. No. The remainder would be 0. Yes, sorry. So therefore, it is going to skip this iteration again. And finally, when I equals 5, 5 is divided by 2. The remainder, is it 0? No, so it's not 0. Therefore, it is going to print 5 for us. So looking at the output, we see that it is skipping the even numbers. It is printing 1, 3, and 5. So let me run the code one more time. So we are printing 1, 3, and 5. You see here in the output, we are having 1, 3, 5. As we expected, we are printing 1, nothing happens. Printing 3, skip this iteration, and printing 5. Let me go through the analyzing of code one more time. So we are having a for loop starting from I in the range between 1 to 6. So I is going to take values between 1 to 5, okay, between 1 and 5. So in case that when we are entering this loop, if I is divided by 2 and the remainder of this division is equal to 0, do nothing and go back up and increase the value of I. Continue is doing basically this thing. Otherwise, print the value of I. So 1 divided by 2, the remainder is 0? No, because it's not an odd number. It's not an even number. So the definition of even number is when it is divided by 2, the remainder must be equal to 0. Therefore, when this does not happen, the number is odd. So by having this line, we can understand if a number is odd or even. So if one number is divided by 2 and the remainder of this division equals 0, it means that that number was an even number. So we are saying that 1 divided by 2, the remainder equals 0. No. So it's not 0, therefore it is not going to continue, it's not going to enter this condition, and it is going to print I, and I was 1, so it is printing 1 in the output, okay? Then I equals to 2. 2 is divided by 2. The remainder equals 0. Yes. When the answer is yes, continue. When the answer is yes, so this condition is passed, so it is entering this part. Okay, when entering this part, it says execute the continue statement. And continue statement means that do not execute the rest of the code for the current iteration. Okay, so for the current iteration, it does not execute the code. It goes back up and I is incremented by 1 value. So I equals 3 now. 3 divided by 2, the remainder equals 0. No, because the answer is no. It is going to print I here. It is not going to enter the continue part, okay? Because the continue part is going to be executed whenever this if condition is true and whenever the statement of the if condition is going to be executed. So printing 3 here, and then for the 4, when I is equals 4, 4 divided by 2, the remainder equals 0. Yes, so continue and do not execute the rest of the code for current iteration. It goes back up, so nothing happens here as you see. I equals 5, 5 divided by 2, the remainder equals 0. No, so if the answer is no, print I for me, which is 5 here in the output. So this is basically how we can use the continue statement to skip the current iteration when certain conditions are met. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that calculates and prints the sum of all numbers from 1 to 10. To do that, I'm initializing a variable called total to be 0. I'm having a for loop and I'm iterating over variable I between the range 1 and 11. So it loops through numbers 1 to 10, okay? And for each iteration, I'm having total plus equal I. So we are checking, we are having the summation of i's into the total variable, and basically here I'm printing out the total. So let me run the code. It says that the sum is 55, but how this 55 is being printed? I mentioned earlier in another coding exercise, when we are having plus equal sign, it means that we are having this formula, total plus I, okay? So this is the formula. So the first time I equals 1, we enter. It means that total equals, so total is initially set to be 0, okay? So new total equals 0 plus I equals 1 plus 1. So total equals 1, okay? Then I equals 2, total equals 1 plus 2. Why? So this one comes from this formula. So this is total plus I. So this one is the value of total which we calculated in the previous iteration to be 1. And this 2 comes from this I that is coming from this I, okay? I equals 2 in this iteration. Therefore, now total equals 3. We have I equals 3. Total equals 3 plus 3 equals 6. Okay, why 3 plus 3? So this 3 comes from this 3. So we calculated the total in the previous iteration, and this 3 comes from I equals 3, because the formula, the new total, is total plus I. Okay, the already value of total plus the current I. And then when I equals 4, we are having the total equals 6 plus 4, therefore total equals 10. Then I equals 5. We are having total equals 10 plus 5. So total would be 15. Then we are having I equals 6. Total equals 15 plus 6. So total equals 21. Then we are having I equals 7. Total equals 21 plus 7. Therefore, total equals 28. Then we are having I equals 8. We are having total equals 28 plus 8. It equals 36, if I'm not mistaken. 26, yeah. 28 plus 8 is 36. And then we are having I equals 9. So total equals 36 plus 9. So the total is now 45. And finally, I equals 10. And total equals 45 plus 10. So total is 55, which is this number that we got here. So basically, in this code, we are iterating over values for I between 1 and 10. We are looping through numbers 1 and 10, and we are calculating and adding the current number to the total number. So total initially equals 0. In the first iteration, total is 0. We are adding the first iteration, I equals 1. So total is now 1. Then I equals 2, 2 plus that previous one. Then I equals 3, 3 plus the previous 3 of the total. So we are increasing the value of 1 to 10 in each iteration to total. So we are having one total, which is summing over all the values that is being iterated between 1 and 10. So it is going to give us the sum of all numbers from 1 to 10. This is how it works, because total starts from 0 and we are increasing the value of the I in each iteration. As you see here, I'm adding 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And these are added to the previous value of I. So you see to previous value of total, because total was 0. So I equals 1. 1 plus 0, it's 1. Then this old value is here, and in the second iteration, number 2 is added to that, so it is 3 now. And the I is 3, we are adding it to already existing total, which is 3, so it's 6 now. 6 is added to number 4, their summation is added to number 5, their summation is added to number 6, their summation is added to numbers 7, 8, 9, and 10. So we reach the output of sum of all numbers from 1 to 10 is 55. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that asks the user to enter the price of 3 items one by one, and we would like to use a loop to collect the prices and calculate the total cost. To do that, we are initializing a variable called total cost to be 0. Then I'm using a for loop starting from I. So the I variable is initialized starting from 1, and ends at 3, because the start is inclusive and is exclusive. So if I type down the range between 1 and 3, I is going to take values 1 and 2, because the end, that 3, is exclusive. So therefore, if we want to ask for 3 items, we need to ask for the range of 1 to 4. So for any I in the range 1 to 4, we are going to ask the user to show the message saying that enter the price of the item 1, for example, item 2, and item 3. And whatever the user is going to enter is going to be converted to float, and then be assigned to the price variable here, okay? And the price variable here is going to be added to the total price. When we are having the plus equal sign, it means that total underline price variable equals to total uh, underscore price plus price. Okay, so this equation equals to this one. They are doing the same thing, but it is a way to write it more concise. So you can write it down like this if it's a bit complex for you or confusing. So it means that the total price, the new total price, equals to total price plus the price. So in the first iteration, the total price equals 0, and the price is whatever the user is going to enter. So imagine that the user is going to enter prices are 20, 25, and 10. Okay, these are the prices. So when I equals 1, price equals 20. So the user is going, we assume that the user is going to enter 20. So total price equals 0 plus 20. Why? Total price, this is the formula, equals total price plus price. So the total price in the first iteration from before that we know that total price equals 0. And then 20 is the number that we assume that the user is going to enter for the first product. So this means that total price equals 20, okay? And in the next iteration, we are having this. For example, when I equals 2, price equals 25. This is just an assumption. And then we are going to, I'm assuming these assumptions because I want to give you a hint and a detailed examples, a detailed explanation of how this total price is being calculated. So total price equals total price plus price. So here it is total price plus price, and total price was 20 from the previous iteration, and the newly entered price is 25, so it is equal to 45 now. And in the last iteration, when I equals 3, price equals 10, because we assume that the user is going to enter number 10, and total price is calculated as the previous total price, which is 45, plus the newly price that is added by the user, which is 10. Therefore, the output will be 55. And we mentioned that in the output, after doing the calculation, we mentioned that total price is 55. So when I run this code, sorry, I'm having an error in this part here. So when I run this code, it asks me enter the price of the item. So I enter 20 first, okay? When I enter 20, it says enter the price of the item again, because there are 3 items that we are going to enter. So the second item price is 25 based on my assumption here, and it again says that enter the item. I'm assuming that the third item price is 10, so it is going to calculate the total price item is 55. Why it asked me 3 prices here? Because we were having a range from 1 to 4, and 4 is exclusive. Therefore, it is going to ask 3 times to enter the total price, and whenever I'm entering the price, it is adding the price to the total price variable, which was initially set to be 0, and in each iteration we added the price that we entered here to this total price variable, so the sum will be 55. So in this example, we learned how a for loop can help us to work as a calculator. For example, in shops, when you're going to a shop and you're giving several items to the cashier, the system of that cashier is using the same mechanism and logic to calculate the total price for you. Thank you for watching. Hello everyone, welcome to this section. In this section, we're going to talk about functions in Python. So a function is a block of reusable code that performs a specific task. Functions can help us to organize our code, make it more readable, and reduce repetition. In Python, there are two types of functions: built-in functions that are predefined functions like print, len, input, that so far we've worked with many of them in the previous sections, and user-defined functions, functions that we create ourselves. This is the function that we are going to learn in this section. So how to define and call a function. A function is defined using def keyword followed by the name of the function and parentheses. Here, I want to show how to create a function. We use the def keyword and we name the function. For example, this function name is greet, and then the parentheses. In the parentheses, we will learn later in this section that we can pass some arguments to these parentheses later on in this section. But for now, we just know that we need to put parentheses. Then a colon. After that, we are having this print function here. So this is the built-in function, and this is the user-defined function. And this function is going to print hello world message for us in the terminal. So when I want to call this function, I simply just type down the name of the function followed by parentheses, and then this function is called and this function is executed. So when I run this code, you should see hello world message in the output. So now it's compiling because it's for the first time. It may take a bit of time. Okay, now we're having hello world in the output. We saw that we only had this function call here one time, and one time this function executed, and this function is simply typing down hello world. So if I call this function more than once, this function is going to be executed. Oh, sorry, greet. So when I call this function twice, this function is being called twice, therefore this part is executed twice. So whenever we call the function, the compiler goes up here, starts with the first line of the function, and this function is only have a single line, so it is going to print hello world. So we saw that how we can create a function and how we can call a function. And there are three parts for function to remember: the def keyword, the name of the function, and parentheses. And later on, we'll learn about some arguments that we may want to include in the parentheses. So here we could, instead of calling this function, I could type down print hello world. And if I wanted to have it twice, I could type it down twice. Okay? And then run the code. It was going to do the same thing. However, we are using the function to avoid repetition. Now I'm repeating this line twice. Instead, I'm having this code being executed here once and avoiding the repetition. Okay, and it is increasing the readability. So this is why we use functions. And this is just a very tiny example here. For example, we want a function to do some mathematical operations for us. Whenever we call the function, that function is going to execute a certain block of codes to do the mathematical operations for us. And calling a function is much easier, like twice, three times, four times. If you want to call a function four times, it's much easier to repeat all those mathematical operations in the code four times. So it increases the readability of the code as well. So in this section, we're going to focus on functions, and we're going to have more examples of functions later on in this section. Thank you for watching. Hello everyone, welcome to this lecture. In this lecture, we are going to talk about parameters and arguments. Functions can take parameters to make them more flexible. So a parameter is a placeholder inside the parentheses in the function definition. When calling the function, we provide arguments which are actual values. Let me illustrate it with an example here. So I'm using the def keyword. The name of the function is greet, and then inside the parentheses, I'm having one argument or a parameter, let's say. Okay, so this parameter is called name. This function, when it is called, it is going to execute this line of code. It is going to print hello message followed by the name that is passed to this function as an argument. Okay, so this function is going to type down hello message and then type down the name. But what is this name? So when in the main part I'm calling this function, in the parentheses I'm passing Alice. Okay, and this Alice, when the greet function is called, this Alice is going to be passed to the greet function as an argument. And here in the greet function, Alice is stored in the name parameter. And here when I'm printing the hello and then putting the name there, here it is going to print out Alice. So when I run this code, here I'm having hello Alice. So hello is the default message of this function. And whenever I'm calling this function, I'm passing one name. And this name is going to be executed and placed here after hello. Okay? And then I'm calling the function one more time, and this time I'm passing Bob as the argument. So when I pass the Bob here, the greet function is going to be executed and Bob is going to place in the name parameter, and the name parameter now holds the Bob value, Bob string, and then it is going to print the message hello and then the Bob here. So we saw that how we can call a function with an argument. But in this case, because this function is having an argument in the parentheses, can I just call the function without any arguments? So let us run. It should be, the answer should be no. So when I run, I'm having an error here. In the previous video example, we saw that there was no error. But why we are having an error here when I'm calling the function with empty parentheses? The reason is that in the definition of the function, we are having the name parameter declared here. So whenever we are calling this function, we are obliged to pass an argument here. Okay, and that argument is going to be printed out in the output of this function. So this function requires to have one argument to be called, and we are passing no argument here. This is why there is an error. But if I have a message here when I'm calling the function, I'm having the Reza Shahin, a string to be passed as an argument for the greet function. Reza Shahin is going to be placed for the name, and then it is going to print hello, and instead of name, because now I'm calling the function with this string, it is going to say hello Reza Shahin. You see here? So this was a coding exercise of how to declare a function, how to call a function, and also how to use parameters or arguments when calling a function. Thank you for watching. Hello everyone, welcome back. In this video, we're going to talk about return statement in functions. So functions can return a value using the return statement. The value returned can be stored in a variable for further use. Let me illustrate it with an example. So here I'm having a function called add. To declare this add function, I'm using the def keyword, and in parentheses, I'm having two parameters or arguments. They are separated by a comma. The first one and the second one. The first one is called A and the second one is called B. Whenever we call this function is going to return A plus B. Okay, so this function is going to add the first number and the second number that are passed to this function by doing this line, return A plus B. So let me show you how I'm calling this function. Now when I call this function, I'm having a variable called result, and this result variable equals the result of this function, the output of this function equals this result variable. So I'm calling the add function. So I'm typing down the name of the function. Then in parentheses, I'm having two numbers and they are separated by a comma, 3 and 5. So 3 is going to be equal to a because this is the first parameter or argument that is passed to this function. And 5 is going to be set to b because this is the second argument that is passed to this function, and b also is the second argument. So I'm calling the add function and I'm passing 3 and 5. And when I'm calling this function is going to return a value for me. It is going to return the value a plus b for me. And a plus b equals 8. So the output of this function is going to be assigned to my result variable here. So 8 is going to be stored in the result. And now I'm printing out the result. So when I have the output, when I run the code, I see that when I'm printing the value of result, I see 8 in the output. I can have, for example, a new variable called x equals add, and then I'm having 2 and 2. I can have y add 5 and 6, for example. I could have z equal add, for example, x and y. And in the output, I would like to have the result of x, then x, print the result of y, then print y, and then finally I want to show the result of z and have the z here. So what I'm doing here is that, again, like the result variable, I'm declaring three new variables, x, y, and z. I'm calling the add function, asking the function add to perform the a plus b with two numbers, 2 and 2. So when I call this add function, the first 2 is placed for the a, the second 2 is placed for the b, and a plus b is going to be returned when I'm having this line, and the result of the return, the output of the function is going to be stored in x. So I expect the value of x will be 4. Then I'm calling the function another time and assigning the result to variable y. And when I'm calling the function, I'm having 5 and 6. So 5 is a and 6 is b. 5 plus 6, the result is 11. So I expect to have the 11 for the y. So 11 is the output of this function, and this is going to be assigned to variable y. And then I'm calling the function one more time, this time with the variable x and variable y, and they are previously taken two values. So I expect the result will be 15 because x is 4 and y is 11. So x is now placed for the a and y equals b. So 4 plus 11 equals 15. So when I run this code, I see the result of x. So here also I'm printing out the output of x, y, and z. The result of x equals 4, which we expected. The result of y equals 11, which we expected. And the result of z equals 15, which we expected. So this is how we can have a return statement in a function to give us some output of the function, and we store that output in, for example, certain variables for further use here. And also we learned how functions can be useful, because now I'm performing this line of code a plus b one time only, but I'm using it 4 times in my code. Instead of typing down these mathematical operations 4 times, I'm just calling it with different parameters. So it is much easier to have a function to do the job for us, and we have different part of the code where we call the function to do that job for us. So we don't have any repetition. We are having the mathematical operations being written only once. This is how it can reduce the amount of code that you're going to write, and how it is going to this is how it is going to improve the readability of your code, because you're typing down the operations one time, but when we are going to have like 10 times of this operation, instead of having it 10 times being repeated in the code, and it would be not very easy to read. It would be hard to follow. Okay, another time I'm having for example, a plus b. Another time I'm having 2 plus 2, 5 plus 6, x plus y, etc. Instead of having these, I'm just calling the function, and the code is being reused several times, and it is being written one time only. So this is how useful the functions are in Python. In the next videos, we're going to dive deeper into this concept. Thank you for watching. Hello everyone, welcome to this lecture. In this section, we are going to focus on lists in Python. So a list is a collection of items that are ordered and changeable. They are created using square brackets, and items in lists are separated by commas. A list can store items of different types, for example, integers, string, or even other lists. And we can access the list elements using index, starting from 0. Let me illustrate it with an example. In order to declare and initialize a list called fruit here, we are having a square bracket here, and there are 3 elements in this list of mine, and they are separated by a comma. So you see here, there are strings. This is why we are having double quotes. There are 3 elements, and they are separated by commas here, and they are declared in square brackets here, sorry. In order to access elements of a list, we can simply use the print function, type down the name of the list, and then the index. Okay, so because our indexing system starts from 0, we are having 3 elements with these indexes. So apple is the first one, so the index is 0. Banana is the second one, the index is 1, and cherry is the third element in this list, but its index is 2. So 0, 1, 2 are the indices in this list of ours. This is very important to note, that all of the lists start from indexing 0. Please keep that in mind. So if I want to print the first element of this list, I'm going to type down the name of the list, and in the square brackets, I'm going to type down the index. So if I want to print apple, I'm typing down index 0. If I want to print banana, I'm typing down index 1. And if I want to print out cherry, I'm typing down the index 2 here. So let me run this code. So when we run this code, we see in the output apple, banana, and cherry. So in this video, we learned about lists and how to create them and how to access the elements of a list. In the next videos, in this section, we are going to dive into deeper concepts of list, and we are going to have some practical coding exercises, so we can have a comprehensive view and understanding of lists in Python. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we are going to talk about how to modify a list. So lists are mutable in Python. It means that we can change their elements by accessing their index or performing certain operations. We are going to write a program to replace the second item in a list with orange. Okay, so our original list is here. So it's called fruit. It has 3 elements: apple, banana, and cherry. And we also learned that the index of banana is 0. The index of apple is 0, the index of banana is 1, and the index of cherry is 2. So we would like to write a program to replace the second item in the list with orange. So the second item in the list is banana. We're going to modify this banana and replace it with orange. But how can we do that? It's very easy. We type down the name of the list and the index of the second item, banana, which is the index is 1. Based on 0, starting from 0, the banana index is 1. And we are setting equal sign to orange. This way, I'm modifying the second element of this list. After that, I'm printing my list. How? I'm using the print keyword and put down the name of the list. So when I run this code, we see that apple, orange, and cherry is being now printed in the output. But what if I would like to change cherry to something else? So for example, I would like to modify cherry. So I would type down the name of my list and the index of my third element, which is cherry, and the index is 2, and I'm going to uh, have the equal sign, and I'm just typing down pineapple. Okay, so now I would like to replace cherry with pineapple and then print out the fruit list. So when I run this code, I see this new list of mine here: apple, orange, and pineapple. So this is basically are the rules of how to access certain elements in a list for further modification. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we're going to learn how to modify a list using 3 predefined functions in Python. First append, then extend, and then insert. So append adds an item to the end of the list. So using append function, we can use only one item each time that we're using and calling this function to the list. Having the extend function, we can add multiple items at the same time to the end of the list. And using the insert function, we can insert an item to the list at a specific position. So let us illustrate these with an example. So we would like to write a program to append orange to the list, extend the list with grape and melon, and then insert kiwi at index 1. Let me illustrate it. So we are having this original list called fruits. It has 3 elements: apple, banana, and cherry. So when I have this list, the index of apple is 0, banana is 1, and cherry is 2. And we were told to append orange to the list. To do that, I'm typing down the name of the list dot append, which is the name of the function, and in parentheses, I'm typing down in double quotes because it's a string, orange, when calling this append function. So one more time: fruits, the name of the list, dot append, and in parentheses, I'm typing down the elements that I would like to add. And because in this case, our item is a string, we are having double quotes, okay? And then I'm printing the fruit list one more time. So here I expect to have apple, banana, cherry, and orange finally in the end. So orange is added after this modification to the list. Previously, we were having up until cherry. So let me comment the rest of the code so we see the output one by one. So when I run this code, I have this fruit list being printed: apple, banana, cherry, and orange. So now we learned how to use append to add orange to the end of at the end of our list. But this append is very useful when we want to add one item at a time to the list. If we want to add multiple items at the same time, it's better to use the extend function like here. So I'm typing down the name of my list, and I'm putting dot extend, which is the name of the function that we introduced above here and here also. And we were told to extend the list with grape and melon. Okay, so when we are having the parentheses, in the parentheses, we need to have a square braces. Be very careful about it. Sorry, square brackets. And then having two items separated by a comma. If we were having three items, we were going to have another comma here, then pineapple, for example, here. Okay. So I'm not going to add pineapple because it was asking only for grape and melon. So we use the extend function. We are having the parentheses here, as we see here. Extend has parentheses, but square brackets are used here and in the start and the end of the function before the end of parentheses, and then we are having grape and melon separated by a comma, and they're in double quotes because they are string. After that, we are printing out the fruit function. So we were having apple, banana, cherry, and orange. So up until here is the same as the last version of our list, but now we expect to have grape and melon in the output as well. So when I run this code, I see apple, banana, cherry, orange, grape, and melon. They are added to the list of ours here in the end. So extend function can help us to have multiple insertion at the same time. Finally, what if we want to add one element at a certain position? For that, we need to use the insert function. And the insert function takes two arguments in the parentheses. First, the index where we want to insert the new element, and in the second part, we are typing down the element that we want to insert. So here we are having the kiwi to be added in the index 1. So when I run this code, I expect to have apple as the index 0, kiwi as the index 1, and then the rest of the list like this as I'm typing down here. So everything as of index 1 is shifted to right because we inserted kiwi in index 1. So when I run this code, we see that kiwi is indeed added at index 1 here. So apple, kiwi, banana, cherry, orange, grape, and melon. So in this video, we learned how to modify a list in Python using append, extend, and insert functions. And we also learned the differences between them. For example, append can add item one at a time to the list, to the end of the list. Extend, however, can add multiple items to the list simultaneously in one go. And then we are having the insert function that can help us to insert one specific item at a one specific index or location in our list. Thank you for watching. Hello everyone, welcome back. In this section, we're going to talk about tuples. So a tuple is a collection of data type in Python that is used to store multiple items in a single variable. They are useful for grouping related data type together, especially when data should remain constant. So now we are going to discuss the differences between tuples that we are going to discuss in this section with lists that we learned in the previous section. So tuples generally are immutable. It means that they cannot change after creation. They cannot be changed after creation, okay? But in lists, we saw that they are mutable. It means that we could add elements, we could remove elements, and generally we could modify the elements. This is not possible to be done in tuples. And when we want to define tuples, we use parentheses. However, when we wanted to define lists, we were using square brackets. In general, in terms of performance, tuples are faster because they are not changeable. They are immutable because of their immutability. However, lists are slower because they are mutable, because we can change them. Because of this option, they are slower. And typically, in terms of the memory usage, tuples are smaller in memory while lists are more using memory size as compared to tuples. And tuples generally are used for fixed data or the constant values, while lists are used for dynamic data that changes frequently. So these are the main differences that we can mention between tuples and lists. In the next videos, we are going to learn how to declare and initialize tuples and how to do certain operations using tuples. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we're going to learn how to create different types of tuples. So I'm typing down my first tuple called empty tuple, and then when I'm initializing it, I'm using parentheses as we discussed earlier in the previous video. And here I'm putting no element for this tuple. So it's a tuple that has no elements, or we can say an empty tuple. Then I am initializing another tuple with one element in it. So it's a single element tuple. And the name of this tuple, I name it single element tuple. It could be X, it could be Y, whatever we want. There is no difference. Then I'm having another tuple called mixed tuple, and it has three elements. One 3.14 and one string called hello. Please note that when we are putting the elements, for example, an integer or a float here, we don't need quotes. But when we are putting a string as one element, we must have quotes. This is something to be careful about, okay? So these are three tuples that we declared and initialized here. One empty tuple and one single element tuple and one tuple that has one integer, one float, and one string. Now we would like to print them. So I use the print function. In the first part, I type down the message that I want to be shown in the terminal saying that, for example, empty tuple, and then one comma, and then type down the tuple name. The same logic goes for the second and the third tuple. Single element tuple in quotes because it's a message to be printed in the output, then a comma, then single element tuple is the name of my tuple that I'm putting there. Again, for the mixed tuple, I'm having the mixed tuple name, a comma, and in the first part, I'm having the message shown in the terminal. So when I run, I see that the message empty tuple that we have here is printed out in the output. And when I have the print of my tuple here, you see empty. So it's only parentheses because it's an empty tuple, okay? But here, when I have single element tuple, it is initialized to be 42. So here we see 42 in the output here. Then when I'm printing out the mixed tuple, I'm having 1 hello and 3.14. So in this video, we learned how to create different types of tuples. In the next videos, we are going to dive deeper into this concept. Thank you for your watching. Hello everyone, welcome to this lecture. In this video, we're going to learn how to access different elements of a tuple and how to do slicing. So I'm having one tuple called my tuple, and it has the elements 10, 20, 30, 40, and 50. So it has 5 elements. And we know indexing starts from 0. So the first element has the index 0, second element has the index 1, third element has the index 2, fourth element has the index 3, and fifth element has the index 4. So now we would like to access the first element in this tuple. To do that, I'm using the print function, and in the parentheses I have two parts separated by a comma. In the first part, I'm typing down the message saying that first element, colon. Then I type down the name of my tuple, and in the square brackets, I type down the index of the element that I would like to be printed out. So now that I want to print out the first element, which is 10, I type down its corresponding index, which is 0, because we mentioned that indexing starts from 0. So when I type down 0, it is going to print 10 for me in the output. Then I would like to print out the last element in this tuple. I could either type down, for example, I could either copy this line and paste it here, and instead I type down index 4 to have this element, the last element, being printed. Let me correct it. Okay, so the last element being printed, or I could type down -1. I could also type down -1 to have access to this element. This one is -1, -2, then -3, etc. Okay, so this is how we can also access elements, start counting from the right to left using the minus. So I type down -1 also to access the last element, or I simply can type 4 here. So let me make it a bit closer to each other. Okay, so yes, and this is for this. Okay, now it's good. So let me run the code up until here. So let me comment the last line. So when I run the code, I see first element is 10, so 10 is being printed in the output using the index 0. Then the last element is 50 using index 4, or we could access the last element using -1, so the last element is 50 here again. We could also, for example, type down, for example, if I want to access this 40, I could either type down the index 3 or -2. So I type down -2 to access this 40 element. I would say element 40. Okay. So when I run this code, it shows the message element 40, and my tuple index -2 is printing the 40 here for us. Okay. But what if we want to print several elements of a tuple? So when I run this code, this part is called slicing. So we slice certain parts of the tuple to be printed out in the output. Okay. So here I'm saying that slice from index 1 to 3, 20, 30, and 40. Index 1 to 3 here. It means 20, 30, and 40. But how I'm doing that? So this is the message I'm showing, slice from index 1 to 3. So index 1 to 3 is this part. It means that it is going to print 20, 30, and 40 for us. Then I type down my tuple name. So the name of my tuple is my tuple. I type down its name. Then I use the square brackets as before. However, I have a colon in the middle. On the left side of the colon, I'm going to type down the starting point, the starting index, let's say, and on the right side of the colon, I'm typing down the ending index. So I'm typing down to start from 1 and end at 4. But we mentioned that we want slicing from index 1 to 3. Why am I typing down 4 here? The reason is that the starting point is inclusive and the ending point is exclusive. So it is going to include index 1 when I'm having this code here. So index 1 is being printed, index 2 is being printed, index 3 is being printed, but the ending point 4, which is this part, is not going to be printed because it is exclusive. So when we want to have slicing from index 1 to 3, we must write from 1 to 4. Okay, just add one number to the ending point because it's a rule that the ending point is exclusive. So in this video, we learned how to access elements of a tuple and how to do slicing for a tuple. Thank you for watching. Hello everyone, welcome back. In this section, we're going to talk about sets. What are sets in Python? Sets are collection of unique elements in Python. They are mutable, but their elements must be immutable. Let me illustrate this concept with an example. Here I'm declaring a set. The set has three elements, 1, 2, and 3. So the set itself is mutable, meaning that I can add an element to it or I can remove one element from it. And when I print my set here, the set was originally 1, 2, 3. I added 4, then I removed 2, so the set will have 1, 3, and 4, these three elements. So it shows that the sets are mutable, so they are modifiable, let's say, in other words. However, the elements of our sets must be immutable. What do we mean by that? So a valid set, for example, is like this. We have one element called hello, one element is 1, and we have a tuple to be one element of this set. So a tuple is inside this set. And it is possible. Why? Because we learned in the previous sections that tuples are immutables. So when we are declaring a tuple, we cannot change its element. This is why they are allowed to be part of a set. However, this set would be invalid. Why? Because one element of this set is a list. So a list is inside this set and it is declared to be one element of our set. But we will have a problem with that because lists are modifiable. So they cannot be a part of a set if they are modifiable because we mentioned that sets themselves are modifiable or they are mutable, but their elements must be immutable. And because here we are having one element as a list, here it will have errors because this element that a list is now an element of our set and that element is modifiable. Therefore, there will be a problem. So we cannot integrate lists inside sets. And sets are generally useful for storing and performing operations on unique data. And one of their key features is that they do not allow duplicate elements. Let me illustrate the differences between sets, lists, and tuples that we learned so far. So sets and lists are mutable. So it means that we can add one element or remove one element from them. However, tuples are immutable. It means that they cannot change after they are created. This is why tuples can be one element of a set, but lists, because they are modifiable, cannot be one element of a set. Regarding the duplicates, sets do not allow duplicate values. However, lists and tuples, it's okay for them to have duplicate values as their elements. Regarding the usage, for unique elements, sets are for unique elements and they are fast membership testing and are very good for mathematical set operations. Lists are usually practical for dynamic collections of elements that frequently change, as we learned in previous sections. And for the tuples are very good. These are very good for fixed collections of elements that should not change. And with respect to the syntax to declare them or to create them, if we want to create a set, we need to define them with curly braces or use the set function here like empty parentheses. To define list, we learned that we are going to use square brackets, and to declare a tuple, we learned that we are going to declare them using parentheses. In the following videos, we are going to talk about different concepts of sets, and we are going to provide a lot of coding exercises so we get familiar in this section with sets in Python. Thank you for watching. Hello everyone, welcome to this video. In today's video, we're going to learn how to create sets and different types of set creation. Here, I'm having my first set being declared using set function. So when I'm having this set function to be assigned to a set variable, it means that I am defining an empty set. So whenever we want to define an empty set, we are going to use the set function. Then I'm having another set being created. It is called numbers, and this set is having 4 elements: 1, 2, 3, and 4. And finally, I'm having my third set being declared here, and it has 3 elements: 1 integer, 1 float, and 1 string. As we see, there is no problem if there are elements of different types, of different data types, let's say. And finally, I'm here printing out these 3 created sets, where I'm showing the message empty set, set of numbers, and mixed data set. And I'm calling their name. So I'm putting the name of my sets, so it is going to print them. When I run this code, I expect to see the sets here in the terminal, the values of the set. So the empty set is returning only this for us. So it says it's an empty set, so nothing to be shown there. And for the set of numbers that we are printing the message here, it is printing numbers variable, which is a set here declared, and its elements are 1, 2, 3, and 4, and we see them in here. And finally, here I'm having mixed data set, which is calling this mixed set, and it contains 3 elements: 1, hello, and 3.14. So in this video, we learned how to create and print elements of a set. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to add and remove elements from a set. I'm declaring a set here, and I'm initializing it to 1, 2, and 3. So there are 3 elements here being assigned to this set, and the name of my set is my set. So in order to add one element to this set, I'm having the name of my set, then the add function, and in parentheses, I type down the value that I want to be added to this set. So let me comment the rest of the code first, and afterwards we're going to investigate those as well. So now I added one element to my set, and this value 4 is added to the set, so the set is updated, and now I'm printing the message after adding 4. Then I'm printing my set. So when I run the code, I see this in the output. After adding 4, this message, and then the set is being printed. Now the set BC has 4 elements: 1, 2, 3, and 4. Previously, it had only 3 elements. So we learned that we can add elements or values to our set. So now we're going to discuss how to remove elements from a set. So our set is now having these 4 elements, and I would like to remove element 2. So number 2, I want to eliminate it from my set. I type down my set dot remove, and then I type down number 2, and then I'm printing the message saying that after removing 2 and printing out my set. So after removing 2, when we compare this set with the last version of the set, the previous version of the set, let's say, we see that number 2 is being removed here. One thing to mention here is that if the set does not have one element, and I type down the wrong element here, so I'm typing down to remove number 5, but there is no number 5 here. So it is going to give us an error. So it's a very good thing to know that if you type down the wrong number, you're going to receive an error from the compiler. There is another way to remove elements in a set. So in order to remove uh, elements in another way from a set, we can type down the name of our set, then use the discard function. And then in the parentheses, I'm going to type down the value or the number that I want to be removed. Then I'm showing the message after discarding 4, and then I'm printing my set here. So when I have this function discard being run, we see that after discarding 4, this message, and we're printing our set. So the previous version was containing 1, 3, and 4. So we discarded number 4 and we see only 1 and 3. So there are only 2 elements left now in the set. And one thing to mention here is that if we type down the wrong element number here in parentheses when using discard function, and when I run, it shows no error to me. So it runs, but it does nothing. Okay, so this is very important to know that. So in this video, we learned how to add or remove elements from a set. And also we learned if we are using the remove function, if we type down the wrong number in parentheses to be removed from the set, and that number is not existing in our set, it is going to return an error. We learned that we can do the same thing with discard function. We can remove elements with the discard function, but the difference is that if we are going to type down the wrong number that does not exist in our set, it is not going to return any error message for us in the terminal, so we are not able to trace it easily if we are typing down the wrong number. So this was it. In the next videos, we are going to dive deeper into the set concepts. Thank you for watching. Hello everyone, welcome to this lecture. In this lecture, we're going to discuss a project. So in this project, we would like to create a simple calculator that performs basic arithmetic operations for us. To do that, first of all, I'm printing the message, welcome to the calculator for the users. So I'm printing out this message. And then I would like to take 2 numbers from the user. First, I ask them to enter the first number, then enter the second number. And then using the input keyword, I'm getting this message being shown in the output for the user and storing this entered data by the user using the input function. And because we learned by default in Python, it is going to store it as a string. We are using the float function to convert the variable, the input variables that is used and entered by the user, to convert them from a string to float. And then this is assigned to my variable called num1. The same logic goes with the second number. I'm showing the message for the user using the input function saying that enter the second number, and the user is going to enter a number. Okay, and that number, using still the input function, is going to be stored as a string for users in the memory. And then, because by default it's a string and we want a number because we would like to do some arithmetic operations, we need to convert it to a float or integer. But float is more flexible. So in order to do that, I'm having the float function and parentheses, and inside parentheses, I'm having the input function. So whatever that is stored using the input function is going to be converted to float, and the resulting value is going to be assigned to my num variable. So I'm using the input function and the float function, okay? And basically I'm having the float, and inside that I'm having the input function, and in this input function I'm having my message, okay? So this is how I'm showing a message to the users to enter 2 numbers.
then storing them as a string, converting them to float, and then assigning them to num1 and num2. Then I'm showing another message to my users. I'm saying that choose an operation, addition, subtraction, multiplication, or division. And then when they want to enter the operation, I'm going to take it as an input and store it in the variable called operation. So here is the fun part. Now I need to define if, else, and elif conditions. Why? Depending on what mathematical operations the user is going to choose, the output is different, because if they choose, for example, the addition, the output should be num1 plus num2. If they, for example, choose multiplication, the output should be num1 times num2 multiplied by num2. Okay, so this is the difference. So now I would like to start my if condition. I'm saying that if the operation variable equals the plus sign, which we store, so we stored the operation that the user is choosing in the operation variable. So if this equals plus sign, the result variable equals num1 plus num2, and then we are going to print the result is, then print out the result value. Elif, the operation equals subtraction, the result variable equals num1 minus num2, and then we are going to print the result. Elif, the operation equals star, we are going to have the variable result being equal to num1 multiplied by num2, and then we are printing out the output here. And elif, another elif is that operations equals the slash. It means that we want to do the division, but before doing that we must check that num2 does not equal 0, because if num2 is equals 0, there will be, mathematically speaking, there will be a problem. No numbers can be divided by a 0, so num2 should not be equal 0. So if num2 is not equal to 0, then result equals num1 divided by num2, and then we are printing out the result. Otherwise, if num2, otherwise is this else function, is else part here, which means that num2 equals 0. Okay, print error, division by 0 is not allowed. And if operation is not equals, the operation variable does not equal to any of these any of these options here, I mean the addition, subtraction, star, and the slash, print invalid operation. For example, if the users enter another operation. So we're going to illustrate it with an example. So let me run the code. When I run the code, it says, welcome to the calculator. Enter the first number. I say 20. Enter the second number. I would say 10. And then enter the operation. I'm typing down the plus. So it says the result is 30. Okay, so it is taking the operation and then do the job for me. So this message was shown, enter the first number, enter the second number, then choose an operation. Then I entered the operation, so it was stored in operation variable. Then because I was choosing this addition, it said if operation equals addition equals plus. Is it true? Yes. Then it entered this if condition here. Because it entered this if condition here, it did the num1 plus num2, stored the result in the result variable, and then print out the output. So when I run this code one more time, it says enter the first number. I said 20. Enter the second number. I would say 15. And choose an operation. And from the operation, I choose subtraction. It says the result is 5. So let me analyze the code one more time. So it stored two numbers that I entered and stored the subtraction sign that I entered here. It start the if condition here. So operation, is operation equal to plus? No, because I entered minus, I entered subtraction. So because this condition is not true, it's not going to execute this part of the code, and it jumps to the elif part. So the next condition, it says operation, is it equal to subtraction? Yes, because this statement is true, it is going to execute this part of the code. Therefore, the result variable is equal to num1 minus num2, which was 20 minus 15, and the result was 5 as shown here. So when I have another run, I would say the first number is 20 and the second number is 0, and I choose the division operation. So it sends me an error saying that error, division by 0 is not allowed. What happened? So the program stored my two numbers. Then it stored the division operation here. It checks to see operation equals plus, no. Then this part is not executed. It jumps to next elif, operations equals minus, no. Then it does not implement this part. It jumps to the next elif, operations equals star, no, it does not implement this part. And then finally it says operation equals slash, which is division, yes. If it checks this statement, num2 is not equal to 0. Is it true? No, num2 equals indeed to 0. Therefore, it comes to this else part and says error, division by 0 is not allowed. This is exactly the thing that we got in the output here. So when I run this code one more time, I say 20 and then the second number 10, and I type down the slash, which means the division, and it says the result is 2. So in this case, it comes here, operation equals slash or division, yes. It checks num2 is not equal to 0, and my num2 was 10. So this statement is true, therefore it is going to implement this part of the code, and result equals num1 divided by num2, and the result is being printed out, which is number 2 here. And when I run the code one more time, I type down 20 and I type down the number 10 as a second number. It says choose an operation. So I choose the AND sign, which is not one of the predefined operations. So when I run this code, it says invalid operation, which is this message here. So when we are having this code and neither of these options are considered here. So the first option is addition. The second option is subtraction. The third option is star, and then this division here, okay? But I chose the AND operation, and AND operation is not included in any of these lines here, okay? So when the AND sign is not included in any of these lines here, it is going to return the invalid operation message because it's the else part. So if operation is either one, either this, and either this, do these things. Otherwise, which is this part, show the message invalid operation. So in this project, we learned how to create a simple calculator that performs basic arithmetic operations for us. Thank you for watching.
Hello everyone, welcome back. In today's video, we would like to write a program that calculates the diagonal of a rectangle given its width and height. Here, because we want to do some mathematical operations, we are importing the math library to use its function. For example, one of the functions that we want to use is the sqrt. So this is why we type down the keyword import and then the math keyword, which means that we are going to use the math library and we are going to import the math library. Then we are going to show this message to the user, enter the width of the rectangle using the input function. And because whatever that we get from the user using the input function, it is by default in Python treated as a string, we need to convert it to a float. And because we want to convert it to a float, we are going to use the float function, and this is the float function. So we are using the float function. So everything that is inside these parentheses is going to be converted to the float. So therefore, I type down the input function inside the float function, and inside the input function parentheses, I say enter the width, for example, and the user is going to enter a number. That number is stored firstly in a string data type, and then it is going to be converted to a float, and the output is going to be assigned to the width variable. The same reasoning happens for the height variable. We are going to show this message to the user saying that, okay, enter the height of the rectangle, whatever the user is going to enter. Firstly, it is stored in a string data type. Then we are going to convert it to a float, and then it is assigned to the height of the rectangle. Okay. Then we are having this variable diagonal equals to the formulation. So this is the formulation to calculate the diagonal of a rectangle. In order to calculate that, we need to have a square root of width to the power of 2 plus height to the power of 2. Okay. And when we are having this output, we are going to calculate its square root, and it is going to give us the diagonal of a rectangle. So in order to compute the diagonal of a rectangle, first we need to have the output of width to the power of 2 plus the height to the power of 2, and then have the square root of their summation. So this formula is written in Python like this. So we call this math function, and we math library, sorry, and then the sqrt function, then width to the power of 2, star star 2 means to the power of 2, plus height to the power of 2, star star 2, and then the output is assigned to diagonal variable. And finally, using the print function, we are trying to print the output saying that the diagonal of the rectangle is, then I type down the name of the diagonal variable, so it is going to print the output for me. So I type down the width of the rectangle is 10, for example, and the height of the rectangle is, for example, 25, and it calculates the diagonal of the rectangle. It says the diagonal is 26. So this is how we can calculate the diagonal of a rectangle given its width and height using the math library and square root sqrt function and to the power of 2 in Python. Thank you for watching. Hello everyone, welcome back. In this video, we're going to write a program that declares a function, and this function takes a temperature in Celsius as a parameter and returns the equivalent temperature in Fahrenheit. Here is my function. So I'm using the def keyword to declare my function. This is the name of my function called Celsius to Fahrenheit. And in the parentheses, it is taking one parameter or argument, and I just name it Celsius. We can call it X, we can call it Y, whatever we want. And this function is basically is going to return the value of this statement. This statement is the following: Celsius times 9 divided by 5 in parentheses plus 32. So this is the very famous formula, and we know it from before, that is going to take a Celsius degree and convert it to Fahrenheit. So this is the formula to do that. For example, this Celsius could be, for example, 30, and I want to know 30 degrees in Celsius is what is the temperature of equivalent of 30 degrees in Celsius in Fahrenheit. So this is the Celsius value, so 30, for example, and then using this formula, we can get the output of the Fahrenheit temperature. Now to do the job for me, I'm having a variable called temp. I call it X for the sake of simplicity. So I'm having a variable X, and we are calling this Celsius to Fahrenheit function. We're calling this function using the argument 25. What does this 25 mean? This means that I'm having 25 degrees in Celsius and I want to know its equivalent in Fahrenheit. And it is going to call this function with 25 equals Celsius. So 25 is multiplied by 9 divided by 5 in the parentheses, and then plus 32. The output is going to be returned. So when I call this function, this is doing this part for me and return its value. So, and the return value is assigned to X variable. Okay, we are assigning it to X variable. And finally, I'm printing out the X variable. So when I run the code, I see the equivalent of 25 degrees in Celsius is 77 degrees in Fahrenheit. We could try like 18 degrees in Celsius and find its equivalent in Fahrenheit. And we see its equivalent in Fahrenheit is 64.4. So this is how we can take a number and do some mathematical operations on that number and return the output. In particular, in this example, we learned how to get a number as the degree in Celsius and do certain mathematical operations to convert the Celsius number to the Fahrenheit number and return the output. And the returned output is stored in variable x, and then we are printing out the x variable. Thank you for watching. Hello everyone, welcome back. In this video, we're going to write a program that declares a function that takes a number as a parameter and prints whether it's an even number or odd. So here is my function. I'm using the def keyword to declare my function, and I'm having the name of the function called check even odd, and I'm having one argument for this function that we call it number. It could be x, it could be y. We can get to choose this number, okay? And this function is basically checking to see a number if it's even or odd. In order to understand if a number is even, we need to do a division. So when this is a definition of an even number. When a number is divided by 2 and the remainder of this division equals 0, it means that that number is even. Otherwise, that number is odd. So let me write it down for you. If a number is divided by 2 and the remainder of this division equals 0, it means that number is an even number. Otherwise, it is an odd number. So this is a definition of an even number. So if a number is divided by 2 and the remainder of this division equals 0, it means that number is even. And if a number is divided by 2 and the remainder of that division does not equal 0, that number is an odd number. Okay? So for example, when 10 is divided by 2, the output of this division is 5, but the remainder of this division is 0. So we understand that 10 is an even number. But when 11 is divided by 2, the remainder of this division is not equal to, does not equal to 0, is not equal to 0. This is why 11 is an odd number. So now we want to define a function that checks whether a number is even or odd. To do that, we are having one if-else condition here. So the number that is passed to this function, we are having this operation on that number. So this number is divided by 2. And we are checking to see if that number that is passed as an argument to this function, it is divided by 2. And it's the remainder of this division equals 0. We are checking the if condition. If this happens, print even. Otherwise, print odd. So it checks to see if a number is passed to this function. that number is divided by 2, its remainder equal to 0. If this statement is true, then this part is true, then it is going to enter this if condition and it is going to print even. Otherwise, it is going to print odd for us. Let me illustrate it with an example. So I call this check even odd function, and I'm passing number 10 as the argument. And I'm calling this function one more time, and I'm calling the function, I'm passing the argument that is 7. So let me run the code. So when I run the code for the number 10, I see even in the output. When I have the number 7, I see odd in the output. So one thing to remember is that I'm using the modular sign here. So the modular sign is going to return the remainder of a division. So this number is divided by this number. When I'm using this modular sign, it means that if this number is divided by this number, print me the remainder, okay? Give me the remainder. So when I'm having, let me illustrate it with an example. So when I have 10 divided by 2 here, when I run this code, you see number 5 in the output, okay? 10 divided by 2. But when I have print 10 modulo 2 and run this code, we have the output 0. What does it mean? It means that if 10 is divided by 2, the remainder of that division is what number? This is 0. Okay, so this is how the modulo sign is going to help us to understand the remainder of a division. It was a very good example. And now we see that here I'm having this block of code being executed whenever we call this function. Just imagine that we were not using the function. So I'm calling the function 2 times using 2 lines. Okay. And this part of the code is written only once. So if I wanted to not have a function, and every time that I was checking a number to see if it's odd or even, I had to write these 4 lines. So whenever, for example, I want to check 10 numbers, each time I had to write 4 lines of code. So 10 numbers multiplied by 4. So 40 lines to check 10 numbers if they're odd or even. However, here I'm having only 4 lines being written only once. And when I'm calling that function, I'm just using 1 line to call this function to do the mathematical work for me. So if I want to call this function 10 times, it will take 10 lines plus these 4 lines that are written only once. It will be 14 lines of code. However, if I want to this mathematical operations, these 4 lines for 10 numbers to be checked, the result will be 40 lines of code. And this is just a simple example. So it is very useful to use functions to reduce the repetition in our code and therefore increase the readability. Thank you for watching.
Hello everyone, welcome back. In this video, we would like to find the third largest number in our list. This is our list. It is called numbers and it has some elements. And we would like to find the third largest number in this list. To do that, I'm printing using the print function. I type down the message third largest number and then I call the third largest function. And this function basically is doing the work for us, and we are passing this list that is called numbers as the argument. Okay, now to do that, I'm having this list being converted to a set using the set function. Why? Because in set we do not allow duplicates. Okay, we do not allow duplicates in sets. So this is why we are first of all, we are converting this list to a set, and then we are sorting this set. I'm going to tell you why not being allowed to have duplicates is important in this example. Then whatever is the output of this part is going to be assigned to the unique number. So we are having a set called unique numbers. So when I run this code, for example, here I'm printing this list, which is called numbers. Then I'm printing this unique numbers set as well here in the output. So when we are having it in the output you see the numbers is the same as we declared here, but the unique numbers is having 2, 5, 7, 9, and 10. So duplicates are removed. We were originally having two number 2s, and we were having two number 7s, but in this unique numbers, we are seeing that we are only having 1, 2, and 1, 7. And this is because of this set function that we use here. So if I remove this set function, and when I rerun the code, I see the unique numbers is being printed here as a list, and as a list when it is being printed you see the duplicates are there. So we are having two number 2s and two number 7s. So this unique numbers is being written here when we are not using the set function. We learned if we would like to access to the largest number, we type down the index -1. So when I type down the unique numbers, then here I'm having -3, for example, it is going to access the third number from right. Okay, so we are looking for the third largest number, and we sorted the list for ourselves here because we are removing the set. Okay, now this is the sorted list, and the third largest number is 7 as you see it here. So -3. So this function is going to basically sort these numbers list, then assign it to unique numbers list. Then we are going to access the third element from the right of this unique numbers list. And here is the third element from the right. We see number 7 is the third largest number. Okay, so in this example, this is correct. But if we wanted to look for the fourth largest number, what would have been the answer? When we are having this -4 here and I run the code, we see still it says let me type down fourth here, fourth. So when I run the code one more time, we see the fourth largest number is -7. So I type down -4 to access the fourth largest number. So this is the first largest number, second largest number, third largest number, and the fourth largest number is not 7 anymore because 7 is the third largest number. But because there is duplicate, the code is making a mistake. So the fourth largest number is 5, but we are having 7 in the output. This is why we need to convert this list to a set. Therefore, this set is going to remove duplicates. So when I run the code, you see the fourth largest number is 5, which is true because first largest number, second largest number, third largest number, and fourth largest number is 5. Okay, so this is important to remove duplicates. This is why we use the set function, and then we sort the converted list to a set, and we are assigning it to unique numbers. Therefore, we are not having any more duplicates in our code. So let me review it one more time. We are willing to find the third largest number. Here, let me type down third again. And let me type down -3 here again. I'm having this list. I'm calling my third largest function, and I'm passing as the argument this list that is called numbers. Then I'm using the set function to remove the duplicates, then using the sorted function to sort it in ascending orders. When we are having a set in ascending order, we can simply understand the third number, the third element from the right will be the third largest number because it is sorted in ascending order and it has no duplicates value in it, okay? And it is assigned to unique numbers here. Then let me just comment these parts because these parts were added because I wanted to show you the output for better understanding and analyzing the code. So then I'm using the name of this variable, which is unique underscore numbers, and using the brackets, I'm accessing the uh, third largest number from the right, because we learned if we type down -1, we can access the number from the right, the first number from the right. To access the second number from the right, we use -2. To access the third number from the right, we use -3. So this is how we can access to the third largest number in our list. Thank you for watching. Hello everyone, welcome back. We would like to write a program that creates a tuple of 5 city names and then convert the tuple into a list, add a new city to the list, and then convert it back to tuple and print the final tuple. So we would like to first write a tuple, convert it to a list, add a new city to the list, and convert it back to tuple, and then print the final tuple. Why do we need to first convert a tuple to a list and then add a city? Why don't we directly add the city into the tuple? Because when we create a tuple, it's not possible to modify them. This is one of the features of the tuples. This is why when we want to add something to the tuple, it's not possible. So a trick would be here to convert the tuple to a list, then add a city to that list and create a new tuple and convert that list into a tuple and assign it to the new tuple. So here, for example, I'm having a tuple called cities. It has London, Paris, Tokyo, New York, and Sydney inside of it. And then this cities is being converted to lists using the list function. Basically, I type down the list keyword, and in the parentheses, I type down the name of my subtuple, and it is assigned to cities list. So cities list is the list version of cities tuple for now. Then I take the cities list and use the append function to add Berlin to my list. So now my list is updated and it has a new city called Berlin. Okay. And now the appending is done. I need to convert it back to tuple and create a new tuple. To convert it to a tuple, we use the tuple function, and I'm using it here, and in the parentheses I type down the name of my list, the updated list, cities underscore list, which has Berlin inside of it as well. Then this is assigned to my variable, which is a tuple, which is called updated cities. Then I'm using the print function, updated tuples, and then put down the updated cities. So when I run this code, I see London, Paris, Tokyo, New York, and Sydney is already there, and Berlin is added, and it's a tuple because we see parentheses here. Okay, so let me review it one more time. So we want to declare a tuple. Then in order to add a new city to this tuple, because tuples do not allow this, we convert this tuple to a list, we append the new city in that list, and then we convert that list to a tuple. And we are going to print the final tuple for us. So this is my tuple. I'm converting it to a list using the list function. And now cities underscore list is exactly equal to this cities tuple because it's just converting from a tuple using the list function, and it is assigned to this. Okay. Then I use the name of my list, which is cities underscore list dot append. Using the append function, I add the new city, Berlin. So now my list is having a new city inside of it. And then I take this cities list in the parentheses and I use the tuple function to convert this updated cities list to a tuple. And it is assigned to a new tuple that is called updated cities. And then this updated cities is being printed in the output. Thank you for watching. Hello everyone, welcome back. In this video, we're going to have another project. So we would like to write a program that calculates simple interest based on user input. To do that, first, I'm showing the message to the user saying that welcome to the simple interest calculator. Then I'm going to ask the user three inputs. The first one is the principal variable, the second one is the rate, and the third time is the time. So I'm going to ask the user enter the principal amount and store it in the principal variable. Then I'm asking the user to enter the rate of the interest in percentages and store it in the rate. And then I'm asking the user to enter the time in years. So the user is going to enter the time and store it in the time variable. Then using this formula, I'm going to calculate variable called simple interest. So this formula is the following: principal multiplied by rate multiplied by time in parentheses, and their result is all divided by 100. And in the output, I'm saying that the simple interest is, and then I'm showing the result here. So when I run this code, it says enter the principal. So I would say 10,000. I would like to apply for a loan, for example, for my car from the bank. And I would like to ask for 10,000. And the rate of the bank is 4.5, for example, percent. And then I'm going to return this in 10, let's say in 20 years. When I want to return it in 20 years, it says that this interest is 9,000. So you're going to pay 9,000 after 20 years of interest to the bank. So now I would like to get a mortgage from bank to buy an apartment, for example. I would type down 100,000. I would say the interest rate is 7, and I'm going to return it in 30 years. It says that after 30 years, I have to return $210,000 to the bank for the initial principal amount of 100,000 with the 7% of the interest for the duration of 30 years. So in this video, we learned how we can provide a program that calculates simple interest based on input user. Thank you for watching. Hello everyone, welcome back. In today's video, we are working on another project. We would like to write down the FizzBuzz program. So a program that to print numbers from 1 to 100, replacing multiplies of 3 with fizz and multiplies of 5 with buzz and multiplies of both of them with FizzBuzz. To do that, I'm having a for loop ranging from 1 to 101, and the reason is I'm having 1 and to 101 is that because the start is inclusive, so we want to go from 1, so I'm typing down the 1. But the end is exclusive, so it says that 101 because the end is exclusive. So if I type down between 1 and 100 because the end is exclusive, it is going to iterate until 99. Okay, so if we want to have until 100, we need to type down 101. And there, when we enter the loop, we are having certain if, elif, and else conditions that we need to check. In order to understand if a number is multiplies of 3, a number is a multiply of 3 if that number is divided by 3 and the remainder of the division equals 0. Okay, this is how we can understand if a number is a multiply of 3 or divisible by 3. So we are going to type down the FizzBuzz message in the output if the number is divisible by 3 and at the same time it is divisible by 5. If the number is only divisible by 3 to print fizz, and if the number is only divisible by 5 print the buzz message. Otherwise, print that number in the output. So in the AND operator, if you remember, both sides of the AND must be true. So if a number is divided by 3 and its remainder equals to 3, and that same number is divided by 5 and the remainder of this division as well equals 0, sorry, it is going to print fizzbuzz message. And if only that number is divisible by 3 to print fizz, if it's only divisible by 5, print buzz, otherwise the number itself. So when I run this code, we see the output here. So number 1 and number 2, the numbers are written like here because neither of these conditions are true for them. Therefore, this else part is true for them. So we are printing out the num. So the variable num that we are initializing here is going to take number 1, 2, 3, 4, 5 until it reaches 100. So for the first iteration, it is 5. It passes none of these conditions and 1 is printed out here. Then for 2, the same thing. For 3, because 3 is divisible by 3, the fizz message is being printed out here. 4 is not, neither of these conditions are true for number 4. Therefore, number 4 is printed out here. Then we are having number 5 here. We are having the buzz here because when num equals 5, 5 is divided by 5, the remainder equals 0. Therefore, it prints buzz. Then for the 6, it prints fizz because fizz means number 6 here, and 6 divided by 3, the remainder equals 0. Therefore, we are having the fizz message in the output. So it goes until it reaches, for example, number 15. And number 15 is divisible by both 3 and 5. Therefore, this fizzbuzz message is printed out in the output. And you see that when I go down, I see all these messages that are printed out here. So in this project, we learned that this num is going to take numbers from 1 to 100 using for loop, and depending on these if conditions, it is going to print certain message or value in the output. Thank you for watching.